right, learning goal for today, the student will understand how to find probability of compound events. So I feel like we have been working up to this for quite a while. We've done every bit leading up to this, and now we finally are going to actually figure out our probability. Okay, so this first slide is just going to kind of give you an overview of probability. This is exactly like simple probability. I mean, you're just picking how many things out of the total. Okay, the only difference is now we have multiple things happening, so you either have to use tree diagrams or tables or detail lists. So let's say that the action is I want to spin the spinner twice, and the event, so like if I said to win the game, you have to get the same color twice. Okay, so my first roll or first spin, I can get red, blue, or green, and then I spin it again, and I can get red, blue, green, red, blue, green, red, blue, green. So there's a total of 9 outcomes here. Okay, remember that always goes to the bottom, so 9 possible outcomes. How many times could I get the exact same color? 3, because this is a red, then red, blue, then blue, green, then green, which would be 3 total times. So that is 3 over 9, which is 1/3. Okay, so that's what we're going to be focusing on. All right, so this first one, they're going to be really nice to us, and they already did the table for us, which makes our life so much easier. All right, so the table shows the possible outcomes of drawing cards, but they're saying that they're replacing the card, and then you choose a second card. Okay, so this is an independent event. Replacing it and then putting it back. All right, so the probability of getting at least 1 apple. Okay, how many outcomes are there total? How many? 5. How many? 25, right? There's 25 different things that could happen. Okay, so do you see the rows that have apples in them? Yes, right here, right? This is fish then apple, star then apple, 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 key then apple, leaf and apple. This would be I draw an apple then a fish, apple then a star, apple then an apple, apple then a key, apple then a leaf. Okay, there's all the different apples. So what would be the probability of me pulling at least 1 apple? 9 out of 25. Does that make sense? There's 9 different things there that can happen, and there's 25 total outcomes. So this would be 5, 6, 7, 8, 9. Make sense? All right, next part then says, what if you can get exactly 1 apple? Exactly 1. How does the probability change? Austin? It'd be 8 out of 25, because which one do I take out? Yes, this one comes out because it's apple then apple. This one's exactly 1 apple. That has 2 apples, so I can't use that one. Okay, exactly 1 apple and 1 fish. So I'm saying you have to get an apple and a fish to be a winner. Sorry.
That's 2 out of 25.
Very good. There's only 2 of them. This would be 1 fish and 1 apple. This would be 1 fish and 1 apple. Those are the only 2 that are there. So that's your 2 out of 25. Okay, and the last one says, okay, you're a winner if you can get at least 1 apple or a fish. Okay, there's going to be a lot more I can add to this, right? So I already have all of the apple ones. Now I got to go in and mark everything with fish. This has a fish, 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 fish. Now how many do I have? I have all of these, so this would be 5, 10, 11, 12, 13, 14, 15, 16. So I can get 16 out of 25 would either give me an apple or a fish, and I'd be a winner. Okay, does that make sense so far? All right, so I want you to go to the next slide, and I want you to try that one on your own and see if you can get the right answer. Okay, so here, this is, you got a fish, right? So that means all of these are winners because it says a fish or an apple. So every time I draw a fish, each one of these times I'm going to win. Okay? This is I draw a star, then a fish, so I win. This is an apple, then a fish, so I win. This is a key, and then a fish, so I win. This is a leaf, and then a fish, so I win. Okay? Now I also have, yes?
What about the apple? What did you circle?
I also have an apple. So the second one, then now I go through and I say, okay, those are all the fishes. Fishes. Okay, so this is a star and then an apple. then a star, an apple, then a key, an apple, then a leaf. So those all work. Then I have a key, then an apple. I have a leaf, and then an apple. So all of those things are going to work because it's that or statement. So how many do I have circled here? I have 4, that's 8, 10, 12, 14. 14 out of how many total outcomes? 25 outcomes. No, not 25. 20 outcomes. And then can that reduce? Yes. What does that reduce to? 7/10. Okay. So on this one, you'd have about a 70% chance of drawing an apple or a fish. You draw either one. Questions on that one before we do one more on our own without the sample space? All right.
4 times 5.
Yeah. 4 times 5. All right. So this one says you're in social studies and you're working on a project, and Mr. Hill has put all of the names for the class in a box. Okay. And then you put all the countries in the other box, and you've got to pick your partner and you got to pick your country. That's basically what this is. And it's saying, what are your chances that you're going to draw your best friend Miguel and your favorite country Greece? That's what we're trying to figure out. Okay. So we have the names still in the box, or Nora, Miguel, Otis. I'm not sure if you say that.
Quincy.
I got Quincy. I'm not sure if that's Pyra or Priya. And I'm not sure either. I'm sure you can pronounce it either way. All right. And then you have your countries left. Okay. So what am I going to have to create here to figure out my total number of outcomes? Yes. Either a tree diagram or a table. On this one, I think it's pretty easy to do the tree diagram because it's only 2 things. So let's create the tree diagram. So we have Nora, Miguel, Otis, Priya, and Quincy. All right, in my second branch, I can have any of those 3 countries. So all of these are going to have, and actually they made this nice, EFG. All right, who can tell me the probability of getting Miguel and Greece?
Is it 12, 15?
Okay, tell me how you're getting 2.
Well, I circled Miguel and France because it's and.
If it's and, it actually has to be both. So and can only be Miguel and Greece. That's the only one. Okay, so if you go with the NF, that's only 1 because that is 1 out of, like if I was gonna make a detailed list, it would be Nora and Ethiopia, Nora and France, Nora and Greece. Each one of those would be 1, not 2. Does that make sense? Okay, if I pick Miguel, I can only do Miguel and Ethiopia, Miguel and France, or Miguel and Greece. That's not 2 options, that's just 1. He goes together because I picked them together. That makes sense?
Yeah.
Okay, so 1 out of, and how many outcomes were there? 15. So if I use my counting principle, I have 5 kids, and how many countries? How many countries? 3. What's 5 times 3? 15. You see how that tells us the total number of outcomes? Okay, good. So 1, 15. All right, let's look at this next one. We are not going to do this whole thing. Oh, hit the wrong button again. Okay, I'm just going to kind of go over 1 or 2 of them so you understand how to do this. All right, so remember we talked about the difference between experimental probability and theoretical. So experiment is you're actually doing something, right? We're going to do some experimenting tomorrow. Theoretical is what should happen in theory. That's the textbook what should happen, okay? So if I look at this first one, it says find the experimental probability of 1 toss and then spinning the spinner. So the event was they got a heads and then they spun a red. They did that 45 times out of 330. So what would be my experimental probability for that box? Exactly, 45 out of 330. So 45 out of 330. And if you notice, mine's a little bigger. I enlarged this picture, so if you need to make yours bigger so you can write in it, I probably should have done that for you. Okay, now, we need to figure out what the theoretical probability is. What should happen in theory when I perform this experiment? Okay, so I think on this one, creating the tree diagram is probably the easiest. So let's create your tree diagram. Or sorry, not tree diagram. I would say looking up puns would totally not be what we're doing right now. Right, Marilyn? Okay, thanks. All right, so let's create a table. Then the table's going to be super easy. Heads, tails, and then this would be blue, red, and green. And let's go ahead and fill in our chart for that. So this would be heads and then blue, tails and then blue, heads and then red, tails and then red, heads and then green, tails and then green. I'll give you a second to finish that. All right, so the next part after figuring out the probability is to figure out what is the expected count going to be. So let's say that I did the trial 330 times. I want to know how many times should I have really gotten a head and then a red. Okay, there's two ways to do this. I'm going to teach you the way to do it with percent. How do I change 1/6 into a decimal? Divide, right? So 1 divided by 6. So 1 divided by 6 is that big number, right? And we've talked about rounding before, so we're going to round correctly. Okay, so if I want to figure out how many times out of 330, 330 is my total. How do I use that number to figure out how many total times I should have rolled that? Yeah, just multiply it. Now, the tricky thing about multiplication when it's like this, because it's a repeating decimal, is when I put this in my calculator, because that's repeating, I'm going to multiply, then you want to put it in like this, 0.1, and then fill your calculator screen with sixes, like that. Then hit times 330. Because if you don't, you're going to get the wrong answer. So what answer should I go with here? 55. Because it's 0.99999 because your calculator can't round it correctly. That should really be 55. Okay, that would be my expected count. Okay, let's do another one that's very similar to this to see if you can do that again. All right, so let's go to the last slide. This is a new one. All right, this one says choose a marble at random from a bag that contains red, green, and blue, and then toss a coin. So it's basically the exact same thing we just did, okay? So let's say that there are 60 trials, okay? So if I would get, let's say, a blue and a tail, okay? This is the exact same table as last time. What are my chances of getting a blue and a tail? 1/6. It's still 1/6. It's the exact same as the other one. Okay, it's 1/6. Okay, how would I figure out 1/6 of 60? Someone other than Cooper, because he answered last time. How do I figure out 1/6 of 60? What? Divide by what? What did I do last time? Austin. Very good. So put it in your decimal form. This is one way. If you have a different way because you're fancy, that's fine. I don't care. This is just one way to do it. So fancy people, however you want. Okay, so I put it in a decimal form, and then there were 60 trials. So I could take 60 times 0.16 repeating. How did I tell you to put that in your calculator? Fill it up with sixes. That's right. So 0.1 filled up with sixes. Then takes times 60, and how many times would I expect to get it? 10 times. Okay, and those of you who are fancy, you might have said, I already knew how to find 1/6 of 60 would be 10. That's perfectly fine. Okay, you don't have to do it that way. All right, questions on that?